This is section 6.1. We're going to start off with a little bit of review of some Algebra 1 skills because these are going to be important for this unit and understanding. We're going to start out with using properties of exponents just to simplify expressions. And again, like I said, these are a lot from Algebra 1. You've seen these before. We're going to jog the memory a little bit, talk about them, and kind of explain how to go through some of these and how to simplify these. Some of these can get pretty challenging, so being able to understand these properties are very important. So when we say exponents, that indicates powers. The table below here is the properties of the exponents. We're going to assume that no denominators are equal to 0, and m and n, in this case, the numbers are integers. They're not decimals or anything like that, or fractions for right now. Okay, so first property that we want to look at here is this one right here, which is that fact that a to the 0 power is 1. Okay, and anything to the 0 power is always going to be 1. Always. All right, so it doesn't matter whether it's a number, a variable, anything to that 0 power is going to be 1. Now, the question is how does that happen? And I can go through a quick review here. If I have a to the first power, that's a times 1, or really a. If I have a to the second power, that's a times 1. Because remember, if you multiply by 1, it doesn't change the value of a problem. Okay? So if I have a to the third power, I'd have a times a times a times 1. Well, you notice, you're seeing a pattern here. The exponent tells you how many a's there are. Well, in this case, if you have a to the 0 power, there's no a's, but there's still that 1 there. So that's why a to the 0 power is 1. Okay, so it kind of gives you an explanation there as well. All right, so let's take a look at the next couple of exponent powers here. There's a couple of them that I want to discuss. The negative exponent rule, okay, in this one right here, anything to the negative exponent, okay, if it's on top of the fraction, it's going to move to the bottom of the fraction. And then your exponent is going to become positive. If it's on the bottom of a fraction, it moves to the top. And then it becomes positive. So whenever you move that fraction, or that whatever that negative exponent is attached to, it's going to become positive eventually. We're going to go through quite a bit of those actually. The other one I want to talk about is the subtraction one with division. If you're dividing two bases that are the same, you can subtract the exponents. Now, notice, out of all of these, all the bases, remember, if I have x to the n power, this right here is the base, and this right here is the exponent. Okay? So you've got a base and you've got an exponent. All right. Now, anytime you have a base, the bases are always going to have to be the same in order to do these exponent rules. Notice you always have an a here. So on this one, on the subtraction one, what I usually say here is we're going to subtract large minus small exponents. And then you're going to leave the base where the large exponent is. And like I said, I'll go through some examples here. Just a quick run through here. If I have, let's say we had 5 to the second over 5 to the third. Those bases are the same. What I would do is I would take 3 here minus 2, okay, to get 1, and that 1 would stay on the bottom. So I'd have 5 to the first power would be on the bottom, and this would just be 1/5. Okay, that's an example. You don't want to necessarily take the top minus the bottom every time, because then you're going to have to deal with negative exponents. And I want to try and stay away from negative exponents if at all possible. Okay. All right, let's take a look at some of these examples now. Okay, it says rewrite each expression using only positive exponents. So again, we got these rules up here. We're going to have to be able to simplify these and come down with an answer. Well, first, what operation are we doing? Well, in letter A, we're multiplying these two. Okay, so I'm going to go ahead and take 5 times negative 3, and I get negative 15. Okay, and on my a, since they both have the same base here, okay, I'm going to take the exponents and I'm going to add them. 3 plus negative 4. Well, in this case, 3 plus negative 4 is negative 1. So I have negative 15 times a to the negative 1 power. Okay. Now, again, because it has a negative exponent, we cannot leave this in our answer. Okay? This needs to go on the bottom of our fraction. Well, what's the number that's on the bottom of our fraction? That's a 1. So essentially what's going to happen here is my negative 15 is going to stay on the top, and my a to the first power is going to go on the bottom. Now, I don't have any negative exponents left in my answer, so now I'm simplified. Okay? All right, so second example, letter B, negative 4 times x to the negative third, y to the fifth, all to the second power. As you look at this here, we're going to use, in this case, we're going to use this exponent rule right here, which is a power of a power rule. I distribute my power through. So I'm going to take this 2, distribute it to the 5, to the 3 exponent, and then I got to remember negative 4 has a first power. So this is going to be negative 4 to the second times x to the, I'm multiplying these guys together, so negative 3 times 2 is negative 6, times 5 times 2, which is 10. Okay? Anytime you have a power of a power like this, you distribute it and multiply. So negative 4 to the second power. Okay, we're going to distribute the negative 4 to the second power here. So negative 4 to the second power is 16 times x to the negative 6th and y to the 10th. Well, you'll notice I have a negative exponent. So this needs to move this negative exponent to the bottom of a fraction. The other two are not moving. They have positive exponents. We're going to leave them where they're at. So on the top, I'm going to have a 16 and a y to the 10th. And on the bottom, I'm going to have an x to the 6th. Okay, again, negative exponent means that we're going to move that power or that base to the bottom of a fraction. Or if it's on the top, if it's on the bottom, we move it to the top. Okay? All right, letter C. Okay, letter C, this is going to be using the property of division right here. Okay, we're going to subtract the bases that are the same. The bases that are the same, we're going to subtract the exponents together. So as you look at this here, I don't have anything else for number-wise, so 4 is going to stay on top. I've got 5 A's on the bottom and 1 A on the top. So 5 minus 1 is 4. Now, since the bigger number of A's is on the bottom, that's where I'm going to leave it. So 5 minus 1 is 4, so this is A to the 4th power. For the B's, I've got B to the 6th over B to the 1st. So 6 minus 1 is 5. And again, I leave it up top because that is where the larger exponent is. And then I've got 3 minus 3. So 3 minus 3 is 0. So essentially, these two C's just cross each other out. And then that's your final answer. Okay? You don't have variables both on top and bottom, and they're simplified. Okay, I'm just going to look at 1 or 2 more examples, and then part of your WSQ is going to be to finish whatever is on the rest of this sheet here. Okay, two problems I want to look at. I want to start here by looking at this guy right here, this top left problem. Okay, so we've got 16 q to the 0 r to the negative 6 over 4q to the negative third r to the negative 7. Okay, so you'll notice first thing we've got q to the 0 power, crossing that guy out because anything to the 0 power is 1. Second thing I'm going to notice is I've got negative exponents. So these guys are negative exponents, so they're going to essentially switch spots. So I have my 16 on the top. I've got my 4 on the bottom. I'm going to take all the negative exponents and move them up top. So the q to the third goes up top. The r to the 7th goes up top, and the r to the 6th goes to the bottom. Now I don't have any negative exponents left. So now I can use my exponent rules here. So first thing I'm going to do here is take my numbers. 16 divided by 4. I've got to simplify those first. That's 4 on the top. Okay. I've got q to the third. I don't have anything else there to simplify it with, so q to the third is going to stay there. I've got 7 r's up top, 6 on the bottom. So 7 minus 6 is 1, and I don't have anything, 1, I've got bigger number on the top, so I'm going to leave this r or r to the first up top. And then I don't have anything on the bottom, so I can just put a 1. Or if you want to just leave your answer as this, that's perfectly fine. Okay, so we've simplified that now. All right, last example I want to look at here is this bottom left problem. And we have a negative exponent out here. Okay, so I'm going to go ahead and we're going to, on the negative exponent, ideally the first thing that you want to look at is you want to flip this. So really this is over 1. Remember, any number is over 1. Okay, and since we have a negative exponent, we're going to flip it around. So I'm going to put 1 on top, and I'm going to put 4 to the 0 power, w to the second, all to the 5th. Now remember, since I moved it, it becomes a positive exponent. The 5 does. Okay. Now I'm going to distribute. So I'm going to get 1 over, still 4 to the 0 power, times w to the 10th. I distribute power of a power. That's to the 10th. Now 4 to the 0 power is 1. So I can essentially cross this guy out. And what I have is 1 over w to the 10th power. Okay, so this concludes section 6.1, the exponent rules. Okay, finish the rest of the problems and also complete your WSQ online.